Today we can see some numerical problems related to the topics in computer network. So first one is the numerical problem on propagation time and transmission time. So these topics are is a part of module 1. So what is a propagation time? So we are having separate formula for propagation time as well as transmission time. So propagation time measures the time required for a bit to travel from source to destination. Okay, so this is a time that is taken for a data or a bit to travel from source to destination. Okay, so what is the formula for this? The transmission time is equal to distance by propagation speed. So distance is what? Distance is the distance between source and destination. Okay, so that distance divided by the propagation speed. Okay, so let us see an example. What is the propagation time if the distance between 2 points is 12,000 kilometer? Assume the propagation speed to be 2.4 into 10 raised to 8 meter per second in a cable. Okay, so we have the formula propagation time equal to distance by propagation speed. So here the distance is given in kilometers, but the speed is given in meters. So we are going to convert this kilometer into meter. Okay, so for that we will become multiplying 1000 with this value. Okay, 12,000 into 1000, so it makes into meter divided by 2.4 into 10 raised to 8. So the answer is 50 millisecond. Okay, next one is transmission time. Next formula, transmission time. The time required for the transmission of a message depends on the size of the message and the bandwidth of the channel. Okay, so there are two factors that is depending upon the transmission time. What are they? The size of the message as well as bandwidth of the message, bandwidth of the channel. Okay, if we divide this message size by bandwidth, we will get the transmission time. Okay, that is the formula. Okay, this formula has to be studied. Okay, so the transmission time is message size by bandwidth. The next question, what are the propagation time and the transmission time? Okay, here, so in this question we have to compute both the propagation time as well as transmission time. For a 2.5 KB kilobytes message, okay, the size of the message is 2.5 KB, and if the bandwidth of the network is 1 GB per second. Okay, so here the message size is given and the bandwidth is given. In that case we can compute the transmission time. So transmission time is what? The message size by bandwidth. Okay, so here look at here the message size is given in kilobytes. Okay, so the kilobytes we have to convert it into bits. Okay, so what we do, we will first of all we will convert it into bytes. Okay, so 2500 bytes into 8. When we multiply it by 8, it will be converted into bits. Okay, so this is 2500 into 8 bits. Clear? Here also 1 Gbps, that also we have converted into BPS, bits per second. So 10 raised to 9 bits per second. Okay, so the transmission time is actually 0.020 millisecond. Now what is that propagation time? That we have already computed. That is the distance is already given. It is 12,000 kilometer. Okay, and the speed is also given. It is 2.4 into 10 raised to 8. It is 8. There is an 8. Okay, 10 raised to 8 millisecond. Okay, so 10 raised to 8 meter per second. So since it is given in meter per second, this 12,000 kilometer is converted into meter. Okay, that is what happening here. Okay, that divided by this one, we will get this one, 50 millisecond. ഓക്കെ, അപ്പോൾ നമുക്ക് ആ ഫോർമുല അറിയാമെങ്കിൽ ഡയറക്റ്റായിട്ട് നമ്മൾ യൂണിറ്റ് മാറ്റിയിട്ട് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ നമുക്ക് ആൻസർ കിട്ടും. ഓക്കെ, സിമിലർ ക്വസ്റ്റ്യൻ. Okay, similar question. What are the propagation time and the transmission time for a 5 megabytes MB message, 5 MB message? Okay, if the bandwidth of the network is 1 Mbps, so it is 5 MB. Okay, so 5 MB we are converting it into bits. Okay, clear? And the network, this is also we are converting into bits per second, so that is 10 raised to 6. Okay, so the transmission time is 40 seconds. So either we can represent it in second or millisecond, that is our wish. Okay, so this is the answer. Now next question, what is the transmission time for a packet sent by a station if the length of the packet is 1 million bytes and the bandwidth of the channel is 200 kbps? Okay, so here they are asking only to compute the transmission time. So the message size is given, which is 1 million bytes. That has to be converted into bits. Okay, so 1 million bytes by 200 kbps, that is the equation. So here, since 1 byte is 8 bit and bytes per second is bits per second, it is equal to 1 million into 8 by 200. Okay, 200 kbps, that has to be converted into bps. So again, so 1 million into 8, it is equal to this one. Okay, 8 into 10 raised to 6 divided by 2 into 10 raised to 5. Okay, so it is 40 second. അപ്പോൾ നമുക്ക് വാല്യൂ കിട്ടിക്കഴിഞ്ഞാൽ നമുക്ക് ഡയറക്റ്റായിട്ട് അതങ്ങ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം, കാരണം അതിലുള്ള ഫോർമുല നമുക്കുണ്ട്. ഓക്കെ, another question, what is the propagation time if the distance between 2 points is 48,000 km? Assume the propagation speed to be 2.4 into 10, it is actually 10 raised to 8. Okay, it is actually 10 raised to 8 meter per second in a cable. Okay, so this question is we have already discussed, similar questions already discussed. So the distance is 48,000 kilometer, that has to be converted into meter. The propagation speed is this one, so you compute the propagation time by dividing the distance by the speed. Okay, so 0.2 is a second. Okay, we can also represent it in a millisecond. Okay, so these are simple questions, questions that may be asked in the university. നമുക്കിവിടെ ജസ്റ്റ് ഈ ക്വസ്റ്റ്യൻ ഈ ഫോർമുല, നമുക്ക് 2 ഫോർമുലാസ് ഉണ്ട്, ആ ഫോർമുലാസ് ജസ്റ്റ് നോക്കുക, അത് ഡയറക്റ്റായിട്ട് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ മതി. ഓക്കെ, അപ്പോൾ മൊഡ്യൂൾ 1 നിന്ന് ചോദിക്കുന്ന ഈ ക്വസ്റ്റ്യൻസ് ആണ്. ഓക്കെ, while preparing for the university examination, you have to go through certain numerical problems that can be asked from certain topics. So the first numerical problem that can be expected is from the topic token bucket. Okay, we have already seen the token bucket algorithm. Here the packets will be, incoming packets will be passed through the bucket based on the token that is available in the bucket. Okay, here there are 3 tokens are available. So 3 at a time, 3 packets will be transmitted from here to here. Okay, so it will take 3 tokens and that and it will transmit the 3 packets from here to here. Okay, so the remaining packets are there, but this remaining packet cannot be transmitted because here the token is not available, the bucket is empty. Okay, since the bucket is empty, token is not available, so this 2 packets cannot be transmitted. Okay, so what are the possible questions that can become? Before that, we have to study 2 formula based on which will be helpful for solving the problem. So let the capacity, so they will give the capacity of the bucket for storing the token. Okay, let's consider it as C. Now the token enter the bucket at a rate. Okay, the token will be entering the bucket, will be entering the bucket at a particular data rate. So that can be represented as R. Okay, R token per second. Okay, per second, how many tokens, that is given here, that is represented R. Now we can compute the maximum number of packets that enter onto the network. Okay, maximum number of packets that can be entered into the network at a time interval t can be it is represented as M, and the formula is C plus R into T. Okay, so C is the capacity, R is the rate, and T is the given time. So C plus RT. Now next formula is the maximum average rate of the token bucket. Maximum average rate of transmission for the for the transmission in the token bucket is given as A, and we are having the formula C plus RT by T. Okay, we have already find the maximum number of packets, that divided by T gives the average rate. Okay, next is the burst time. They will ask the time, what is the total time taken for the transmission of the packet. Okay, that is called the burst time. So that is explained, that can be computed using the formula C by M minus R. C by M minus R. So what is C? C is the capacity. M is the total number of maximum packet. Okay, maximum number of packet, and R is the rate. Okay, so we have to memorize these formulas. Okay, memorize these formulas for computing the required quantities. Okay, now let us go through a problem. Consider a token bucket of capacity 800 MB. Okay, here the bucket has a capacity of what? 800 MB. So capacity is represented as C, right? So C equal to 800 MB. And the tokens arrive at a rate 100 MB per second. Okay, the rate of arrival of the token is what? 100 MB per second. Okay, 100 Mbps. Okay, instead of writing MB per second, I have written Mbps. Mbps is same as this one. Okay, so 100 Mbps. Now, if the maximum output rate is 300 MB per second. Okay, here the M value is 300 MB per second. What is the burst time? What is the burst time? Okay, how to calculate? Burst time is also known as the time at which the data or the packet can be transmitted. So we have already have the formula for the burst time or the duration, that is T equal to C by M minus R. Okay. So given C capacity 800 MB, the data rate R equal to 100 Mbps, and the maximum output rate is also given 300 Mbps. Okay. So applying that values, we will get the answer 4 seconds. Okay, 800 MB divided by 300 Mbps minus 100 Mbps is equal to 4 seconds. Okay, so here MB, this megabyte will be cancelled and only the second will be left over. Clear? Next question. A computer on a 10 Mbps network is regulated by a token bucket. Okay, the token bucket is filled with the data filled at a rate of 2 Mbps. Okay, so here the data rate R equal to 2 Mbps. The token is filled into the bucket at the rate of what? Equal to the rate of 2 Mbps. It is initially filled to the capacity of 16 megabytes. So initially the token bucket is having a capacity of what? 16 megabytes. Okay, C equal to 16 MB. Clear? Now what is the maximum duration for which the computer can transmit at the full of 10 Mbps? So here also we are going to compute the burst time. Okay, instead of burst time they have given the duration, maximum duration. So what is the maximum duration for which the computer can transmit at the full 10 Mbps? Okay, so the maximum output rate is 10 Mbps. Okay, so here M, the value of M is 10 Mbps. Okay, the same, R equal to 2 Mbps, C equal to 16 MB, and M equal to 10 Mbps. So all the values are there. We have to find the duration. So T, for T we are having a formula C by M minus R. Applying that we will get 2 seconds. Okay, clear? Next question, similar question. Computer on a 6 Mbps network is regulated by a token bucket. The token bucket is filled at a rate of 1 Mbps. So the bucket is filled at the rate of 1 Mbps. So R equal to 1 Mbps. It is initially filled with the capacity 8 MB. Okay, so the capacity of the bucket is how much? 8 MB. Okay, so how long can the computer transmit at a full 6 Mbps? Okay, so the maximum output rate is 6 Mbps. Okay, so same, apply the same for here also. You have to compute the what? How long? So long means time. Okay, long in the sense you are going to compute the duration or the burst time. Okay, so T equal to C by M minus R, 8 by 6 minus 1, which is 1.6 seconds. Okay. Next question. Next we can expect questions from our IP address. Okay. So for solving the problems of IP address, we must understand the classful IP addressing. In that we have seen that the IP address is being divided into different classes. Class A. So I hope all of you know this, knowing the structure of an IP address. Okay, an IP address in the form of bytes. Okay, so each there are 4 bytes, and these 4 bytes are separated by a gap. Okay, so this is the first byte, second byte, third byte, and fourth byte. To identify the class of the IP address, we just look at the first byte. If the first byte is ranging between 0 to 127, it will be class A. Between 128 and 191, it is class B. 192 and 223, it is class C. 224, 239, class D, and 240, 245, class E. Okay, this is the classful addressing. Also we must understand the default masking of the the IP address. What is the use of this IP masking? Masking is used to separate the from the masking we'll be able to identify the host ID as well as the network ID. Okay, in IP contains host ID as well as network ID. Using this masking process, we can able to identify the host ID as well as network ID. In class A addressing, you can see that the first byte, only the first byte will be the network ID, and the remaining bytes will be remaining 3 bytes will be the host ID. Okay, so here the default masking will be like this: 255.0.0.0. Okay, the first byte will be intact. Okay, and the second byte, the second, third, and fourth will be changing. So that will be the host ID, and the first byte will be the what network ID. Okay, now in class B, the default masking is 255.255.0.0, which means that the first two, this is the first byte and this is the first byte. So byte means 8 bit. Okay, the first 8 bit and the second 8 bit. So first byte and the second byte will be representing the host ID. The remaining bytes will be representing the the first 2 bytes will be representing the network ID, and the remaining 2 bytes will be representing the host ID. Okay, so the default mask will be like this. Now in the case of class C addressing, the first 3 bytes will represent the network ID, only the last byte will represent the host ID. Okay, so the default masking will be like this: 255.255.255.0. Okay, so in 255 is actually 255 means 8 ones in binary. Okay, that is why it is written like this. Okay, so this is the binary notation, and this is the dotted decimal notation, okay, of the mask. Now let us see the question. A block of address is granted to a small organization. We know that one of the address is this one, 205.16.37.39 bar 28. What is the first address, last address in the block? Compute the number of addresses also. Okay, so this problem we have already discussed. Anyway, I am going to revise it once more. So the given IP address is 205.16.37.39 bar 28. So bar 28 means the first 28 bits starting from left will be 1. Okay, that will be the mask. So here the IP address, this is the IP address, and this is the binary for this corresponding IP address. So 205 is written in 8 bit, 16 written in 8 bit, 37 written in 8 bit, 39 written in 8 bit. So here it is written that /28. /28 means the subnet mask or the mask contains 28 ones and the remaining 4 zeros. Okay, so why? Because the remaining 4, because the total length is 32 bits and IP address contain totally 32 bits. So the first 28 bits will be 1, and the remaining is the what? Remaining 4 bit will be the remaining bits for this corresponding mask. Okay, now so we will take the 28 bits. We will take the 28 bits of the given IP address. So we will take from this binary, we will take up to the 28 bits. Okay, this is up to 28 bits, and the remaining 4 bit will be changing. Okay, So we will take the first 28 bit, this will be intact, this will not be changed. Only the last 4 bit will be changing. Okay, so how can we send the first, how can we represent the first address? We'll be setting 32 minus 28, that is the 4, the last 4 bits will be represented as the 0. Okay, last 4 bit will be represented as the 0. So that will be the first address. Okay, so how the output IP will be changing? Okay, up to 28 bits the IP is same. Up to 28 bit the IP is same. Look, up to 28 bit the IP is same. Okay, and the last 4 bit will be zeros for the first address. Okay, then what will be the last address? The last 4 bits will be 1. That will be the last address. Okay, so this is the first address. So we will this is the binary representation. Now we will make it into decimal notation. So it will be 205.16.37 and the last byte is 32. Last byte is 32. Okay, now the last address. The last address is what? The last 4 bit will be represented as 1 instead of 0. Okay, but 0 ആയിരുന്നു last 4 bit. Now last address കണ്ടുപിടിക്കാൻ last 4 bit നമ്മൾ 1 ആയിട്ട് represent ചെയ്യും. Okay, so the corresponding IP in decimal notation is 205.16.37.47. Clear? Now the last question is compute the number of addresses. So using this 4 bits, how many addresses can be, we can generate how many addresses? That is 2 raised to 4. Clear? 2 raised to 4. Here I have missed out 4. So 2 raised to 4. So 2 raised to 4 address can be generated from this 4 bits. Okay, so 16 addresses can be generated. Clear? So this is one such question. Now next question is another type. A network on the internet has a subnet mask of 255.255.240.0. What is the maximum number of hosts and subnet it can handle? So in this question they are asking to compute the number of hosts as well as number of subnet. Okay, this is another method of question. So we have to take the subnet mask. We have first of all we have to take the subnet mask. It will be given 255, 255, 240 and 0. Okay, so from this we have to identify this is of which class. Okay, this is of class B. Why? Because in class B the first 2 bytes will be 255. Okay, the remaining 2 bits will not be 255. Okay, look at the representation. Look at here, in class B the first 2 bytes will be 255, the remaining 2 bytes will be 0. Okay, it can be 0 or can be anything. Okay, so this is the method. So from the subnet we can understand that the first 2 byte will represent what? First 2 byte will represent the network ID and the remaining 2 byte will represent the host ID. Okay, so here this is the binary representations. Okay, so the first 2 byte up to this will be the net ID and up to this will be host ID. Okay, this is the host ID. Clear? Hope you are clear. Now look at the question. Okay, now look at the question. So we have classified the net ID as well as host ID based on the subnet mask. Okay, so we have found out what is net ID and what is host ID. Now look at the question. What is the question? We have to compute the maximum number of hosts and maximum number of subnets. Number of subnets and number of hosts, that has to be computed. So how to compute the number of hosts? Okay, so number of hosts, if you want to compute the number of hosts, you go to the host ID part. So this byte, this 2 byte represent the host ID, right? In that host ID you count the number of zeros. Okay, number of zeros, how many zeros are there? This is 8 and this is 4, so totally 12 zeros are there. Okay, so for representing the host we will be having 12 zeros. Clear? Now the total number of hosts available is equal to 2 raised to 12 minus 2. Okay, so the formula is 2 raised to 12 minus 2. So we will subtract 2 from the 2 raised to 12. Why? Because the first address and the last address is actually reserved for another purpose. One is for broadcast purpose and another is for the subnet address. Okay, so that is so those two addresses we will not be taking. Okay, so we have to compulsorily subtract 2 from the 2 raised to 12. So that will be the total number of hosts available. Okay, so total number of hosts is equal to 2 raised to 12 minus 2. Clear? Now we have to compute the subnet, number of subnets. Okay, to compute the number of subnet, again we have to look into the host ID part. Okay, so this is the host ID part. In this host ID part, how many ones are there? There are 4 ones. Okay, so 4 bit represent is having ones. Clear? So that will be the number of bits available for the host. So that will be the number of bits available for the host, which is 4. Clear? So the total number of subnet will be 2 raised to 4, which is equal to 60. Clear? So here we don't have to do any subtraction or not. We can directly take the 2 raised to power. Clear? So 2 raised to 4 equal to 60. So total number of subnet is 2 raised to 4 equal to 60. The total number of hosts is equal to 4096, which will be 2 raised to 12 minus 2. Clear? This is the question. So from this, mostly they will be giving the IP address or the subnet ID like this. From this, they will ask to compute the host ID, number of hosts as well as number of subnets. Clear? Next question. How do you subnet the class C IP address 206.16.2.0 so as to have 30 subnets? What is the subnet mask for the minimum number of hosts? How many hosts each subnet can have? So what all things are given in the question? They have given the IP address. Okay, they have only given the IP address. They have not given the subnet mask. So the given IP address is 206.16.2.0. So from this we have to identify which class is this IP address belongs. Okay, you can go to that first to take the first byte. First byte is 206. Okay, you just look into the table 206. 206 will be occurring it where in the class C. Okay, so this is a class C address. Clear? If the class C is the addressing, the default subnet mask will be this one, 255.255.255.0. Okay, 255.255.255.0. Okay, so we can easily find that the last byte represent the host ID, and the remaining 3 bytes, the first 3 bytes will be representing the network ID. Clear? Now that is over. Next, another thing it is already given is the 30 subnet. Okay, here they are telling that they require 30 subnet. In the previous question, we have computed the subnet number of subnets. But in this question, they have given that there are 30 subnets. Okay, so here we have to know how many bits will be required for representing this 30 bits. ഈ 30 സബ്നെറ്റ്സ് റെപ്രസെൻറ്റ് ചെയ്യാൻ നമുക്ക് എത്ര ബിറ്റ് വേണമെന്നുള്ളത് നമ്മൾ ആദ്യം നോക്കുക. ഓക്കെ, സോ ദ ബിറ്റ്സ് നീഡഡ് ടു അക്കോമഡേറ്റ് 30 സബ്നെറ്റ് വിൽ ബി 5. Okay, which will be around 5, because if it is 4, it will be 2 raised to 4 is how much? 2 raised to 4 will be 60. Okay, that is not possible. 2 raised to 5 ആണെങ്കിൽ it is correct, it is 32. Okay, because 30 is sufficient for this 5 bit is sufficient for this 30 subnet. Clear? So we will take this 5. So 5 bits are required for accommodate this 30 subnets. Clear? So 2 raised to 5, you include here 5, 2 raised to 5 equal to 32 subnet possible. Clear? So now we will rewrite the subnet mask. We will finally we will rewrite the subnet mask. So subnet mask, since it is class C, the first 3 bytes will not be going to change. So it will be 255, 255, 255. Okay. So the bits will be like this: 1 1 1 1 1, 8 ones, 8 ones, 8 ones. No change. Okay. Now the last byte. Okay, so this last byte is sending the host ID. Okay, this last byte tells the host ID. In that, they have told that 5 bits. Okay, 5 bits must represent what? 5 bits must be required for obtaining the subnet, number of subnets. Okay. So the first 5 bits will be, we will put the first 5 bits as 1. Okay. So 1, 2, 3, 4, 5. So the 5 bits, the first 5 bits will be 1. And the remaining 0 bits, remaining bits will be 0. How many remaining bits are there? Will be there 3 bits, because 5 bits after writing 5 bits here, the remaining is 3 bits, because total it is 8 bits, because 1 byte അല്ലേ ഒരു ലൊക്കേഷൻ ഒരു പാർട്ട് എന്ന് പറയുന്നത് ഇറ്റ് ഈസ് 1 byte ആണ്. Okay, 5 bit I have represented here. Now remaining is the 3 bit. So this 3 bit I will be representing as 0. So 3 bit will be representing as 0 അല്ലേ. നമ്മൾ ഹോസ്റ്റ് ഐ ഡി കണ്ടുപിടിക്കുക, നമ്മളെപ്പോഴും അത് 0 ആയിട്ട് റെപ്രസെൻറ്റ് ചെയ്യും. So okay, so how many bits are there for representing the host? There are 3 bits. So 3 bits are there for host ID. Okay, so the bit left for the host is 3 bit. Clear? So the total possible host will be how much? Total number of hosts is how much? It will be 2 raised to 3 minus 2. Okay, why it is subtracting 2? Because the first two addresses are reserved for broadcasting and some other purpose. Okay, that will not be taken. So that is where we are subtracting 2. So the total number of possible hosts will be 2 raised to 3 minus 2, which is 8 minus 2, that will be 6. Okay, so this is the way I have to compute the number of hosts. Okay, in this question we don't only have to compute the number of hosts, but number of subnet is already given. Okay, now another question. Look here. How do you subnet the class C IP address 195.1.1.0 so as to have 10 subnet with the maximum 12 hosts in each subnet? 12 hosts in each subnet. This is subnet, SUBNET, subnet. Okay, 12 hosts in each subnet. So we have already given the IP address. IP address is what? 195.1.1.0. This is the IP address. It is already given. So 195.1.1. So this 195. So this is of which class? From 191, this is of class what? Class C, right? Class C, starting from 191. So this 192, this IP address, this 195 will be in class C. Okay, so this is a class C IP address, and the default subnet mask will be 255.255.255.0, right? 255.255.255.0. Okay, now they have given the number of subnets. How many subnets are there? 10 subnets are there. Okay, to represent 10 subnet, how many bits will be required? For representing 10, how many bits will be required? 2 raised to 4, right? Because 2 raised to 3 is how much? 2 raised to 3 is 8. Okay, that is not sufficient. 2 raised to 4 is 16. So 16 is sufficient. So 4 is sufficient. Okay, so 4 bits are required. 4 bits are required for representing this 10 subnets. Okay, now we will write the masking. So 255, 255, 255. So the first 3 bytes will be 1. Okay, 1, 1, 1. Okay, then this represent this last byte represent the host ID. Okay, from that how many ones must be put? We have to the first 4 bits will be represented as 1, because that is the that represent the number of bits for the subnet. Okay, so the first 4 bits will be represented as 1. Okay, if the first 4 bits are represented as 1, then how many bits are left? Remaining are 4 bits. That 4 bits will be represented as 0. Okay, so 0 0 0 0. So these remaining 4 bits will be the number of bits for the host. Okay, so the remaining zeros. So how many remaining zeros are? So how many bits are there in zeros? There are 4 zeros. So 4 bits. So these 4 bits will be representing the host. Okay, so bit left to represent the host is equal to 4. So total number of hosts possible is 2 raised to 4, 2 raised to 4 minus 2. Okay, 2 raised to 4 minus 2. Okay, which is equal to 14. Clear? So 14 hosts are required. Okay, so this is a very important. These are gate level questions, very important questions. Okay, so this such questions can be surely asked in the university. Okay, now next question. Another possibility of asking question, which is find the net ID and host ID of the following address. Okay, now so this is the question 114.34.2.8. Okay, so how to know the host ID and the net ID and the host ID, network ID and the host ID. So you just look at the first byte. Okay, and first byte, and you check whether this IP address belongs to which class. So 114, this 114 belongs to class A, right? Because 0 to 127 is class A. So this 114 belongs to class A. Oh, okay. So class A means what is net ID? The first byte will be net ID, and the remaining 3 bytes will be host ID. Okay, so only the first byte, the 255 part will be the host ID. The remaining are the zeros part, that will be the host ID. Okay, so the first part only, the first byte will be the net ID. Okay, so 114 is the net ID, and the remaining 3 bytes 34 to 8 are the host ID. Clearly? Similarly, you do the rest of the question. 132.56.8.6. 132, look at the first byte. 132, you have to find the class. Which class 132 belongs? 132 belongs to class B. Okay, which is class B. What is the mask? Mask means 255, 255.0.0. That is first 2 bytes. This by 1 byte and the second byte. Though these first 2 bytes represent what? First 2 bytes represent the network ID, and the remaining 2 bytes represent the host ID. Clear? So from this question, 132 and 56, 132 and 56 are the net ID. 8 and 6 are the host ID. Clearly? Now, third question, 208.34.98.12. Okay, so 208, in which class this belongs? This belongs to 208 means it is coming under the range 192 and 223. Okay, it is becoming class C. So in class C, we can see that the first 3 bytes represent the network ID. Okay, first 3 byte lele 1 ulladu, that represents the network ID. The last byte represents the host ID. Okay, but 255, that part, that first 3 byte represent the host ID, and the remaining last byte represent, the first 3 byte represent network ID, and the remaining last byte represent the host ID. Okay, so in this question 208.34.98. okay, so this first 3 byte 208.34.98 represent the net ID, and 12 represent the host ID. Okay, so similar questions can be also coming. So in IP, there can be chances of occurring 3 different types of. This is one type. Another is for computing the number of hosts and the number of subnet, and another one is the computing the first address, last address, and number of address range. Okay, so this can be the chance there. These are the questions that can come from the topic IP address. Okay. Next numerical problem can be occur from the CRC problem. That also must be you have to go through the CRC problem, and also the Hamming code problem also you have to go through. Okay, clear? So kindly go through all these problem. Okay, this will be a IP related question, will be a sure short question for tomorrow's exam.